Greetings to every one of you. So in this video we are going to discuss non-primitive data structures. Data structures can be divided into mainly two types. One is primitive data structures and another is non-primitive data structures. Normal integers, real, character, boolean, they are called primitive data structures that we discussed in our previous video. So these non-primitive data structures are divided into mainly two types. One is linear and another is non-linear. Arrays, linked list, stacks, queues, all these data structures comes under linear data structures. In linear data structures, each and every element, it has a unique predecessor and the successor. Let me start from arrays. Array is a list of finite number of elements of homogeneous data types. So the data of the same type is called homogeneous data types, like integers, real, characters. List of marks of students of a particular class, price values of the different products, names of the employees. These are some examples of arrays. The elements can be accessed by the index of the array. For example, mark of I. So here the mark is the name of the array, and this I indicated inside the bracket is called the index. Array can be, that is one dimensional, that is the linear array, in which the values will be stored continuously. As far as the memory concerned, it needs the continuous block of memory in order to store the values of the array. For example, this is mark 1, this is mark 2, mark 3, mark 4, etc. In two-dimensional array, two index values are required. Similarly, in case of n-dimensional array, we need n index values to represent the n-dimensional array. So matrices are very good example for two-dimensional array, in which we will have two index values. So this I represent the number of rows and this j represent this number of the columns. So the position of each and every element can be represented with the help of these index values. See, for example, this element, this present in the location, the second row and the second column. So this m of 2, 2, it is nothing but 5. This is how we can locate the element in the two-dimensional array. I move on to the next linear data structure, that is linked list. It is a linear collection of data elements called nodes. The linear order is maintained by the pointer or links. They are also referred as addresses. So mainly these pointer or links which are used for traversing from one node to another node. A linked list can be linear, there is one way. It is also called a singly linked list, in which we will have only one link, that is one pointer, apart from the information or data. Similarly, in the two-way linked list, it is also called a doubly linked list, in which we will have two links. One is left link and another is right link, along with the information. So sample example of the singly linked list is given here. we have the starting address, that is 3. So it starts at the location, that is 3. The value of the location 3, the information contained in location 3 is nothing but J. Okay. Then the link part of the 3 contain the value, that is 6. This is the link part of 3. So go to, that is location 6. So the information part of the location 6, it is A. And the link part of the location 6, link part of location 6, it is nothing but 4. And go to 4. In 4, the information part of location 4, it is nothing but M. And again, the link part of the location, that is 4, it is 8. The information part of location, that is 8, it is nothing but A. And the link part of the location 8 is nothing but 1. And go to 1, and the information part of location, that is 1 is equal to, that is L. And the link part of the location 1 is equal to, that is 0. So which is nothing but null. So here the list get terminated, and you can see that the word, that is Jamal, it is stored in the different location, not in the continuous block of memory. It is stored in the different locations. So that is the major difference between the arrays and the linked list. Whereas in array you need a continuous block of memory, so whereas here we can store the different locations. The next linear data structure, that is stack. It is a data structure in which insertion and deletion can take place at only one end, called the top. It follows a principle, last in first out. Last can be, that is taken out first, or first in last out. The element which is inserted first, that is here, that can taken out at last. So that is one is LIFO, last in first out, and another is first in last out. The next one is Q. This is a data structure, follows the principle called FIFO, that is first in first out. So it is a linear list in which insertion can take place at one end of the list called rear, and deletion can take place at other end called the front. So insertion can be, that is done through the rear end. We can delete the items from the front end. So first in first out. I move on to the non-linear data structures. There are two types of data structures that is available under non-linear. So one is trees and another is the graph. Let us see tree. Tree is a data structure that represents a hierarchical relationship between the various elements. So mainly it follows the parent-child relationship. So this is an example which we have the different nodes are get connected. So node 1 and 2, 3, 4, etc. The first node is called the root node, and we have the levels like level 0, level 1 and level 2. So if you say this is the parent and these are the children. So there is only one path connect the two nodes. If you take these two nodes, the connection between these two nodes are by this only one edge. So that is the main the criteria of the trees. I move on to the second one, that is a graph. A graph G is an ordered set V comma E, where V represent the set of elements called nodes or vertices, and E represent the edges between these vertices or the elements. They are used to represent relationship between pair of elements which are not necessarily hierarchical in nature, that is different from the tree structure. That is, in graph, the nodes are connected by more than one path to each other. So whereas in the tree structure, we have there is only one path between the two nodes. This is an example of a graph, but here you see, for example, if you take C, in order to reach C, we can reach it from A, and also we can reach it from D, also from F. These are the vertices, the nodes are these are the vertices, and a line which is connecting the nodes, that is what is called the edges. So in this video we have discussed the different types of non-primitive data structures, in which we discussed about linear data structures like arrays, linked list, stack, queues, and in non-linear data structures we discussed about the trees and the graph. I hope you understood. Keep watching. I'll continue in the next video. Thank you.